Ever tried looking directly towards the sun? Seems evenly bright with the same color yellow. If you observe closely with the help of instruments like a telescope projector or a sunspot viewer, you would notice bright and dark regions on the sun's surface. Viewing more closely, one can even notice dark spots on the sun's surface. The sun, a bright sphere all made up of hot plasma of hydrogen and helium, has a ridiculously huge mass. All the fission reaction that is taking place inside the sun produces immense energy, and the byproduct, which is helium, produces a lot of pressure internally. This pressure results in the sun spewing out electrically charged particles, and this phenomenon is known as the solar wind. The sunspots are the regions where intense magnetic activities happen. These are way cooler and darker than the other regions of the sun, and even after being cooler, they shine 10 times brighter than the moon. Sun rotates fast, but since the gases are lighter, the velocity of these gases at the equator is high, and thus current of plasma causes twisting and turning of the magnetic field lines. When these currents causes bundling and braiding to the magnetic lines, it distorts to an extent at which it pops out, causing plasma along with these magnetic field lines to make a loop, starting from one sunspot and ending in another. Sunspots are simply the points from where these magnetic fields arise. When the loop of magnetic fields arises, the plasma moves along with the fields, and at the sunspots, as the line moves closer and closer, they diffuse and burst to form two fields. One, the main magnetic field that is inside the sun's surface, also referred to as the corona, and the other one which travels away from the sun. A solar flare is composed of charges and radiations, along with its own magnetic field, so it has much less mass and has a capability to move at near light speeds. Hence, it would reach Earth in the time it takes for sun's light rays to reach Earth, which is about 8 to 9 minutes. Less intensity solar flares and solar wind are easily shielded off by the planet's magnetic field, and its effect is redirected towards the poles, causing the widely known phenomenon of northern lights. Northern lights, also known as aurora borealis or just auroras, this phenomenon creates dynamic patterns of vibrant colors, of fluorescent colors, and are found in the forms of curtains or rays-like appearance. They cover the whole sky at night. They develop as high-velocity charged particles from the sun collide with various gases of the atmosphere to release energy in form of distinct colors of light. Similar phenomenon is observable on other planets like in Jupiter's atmosphere. Now one would imagine, how can solar flares harm us anyways? Because we are actually protected by the Earth's magnetic field lines, but there are even higher strengths of solar flares or higher magnitude solar flares, which are known as solar storms or coronal mass ejection. When they do hit Earth, they can cause financial crisis. Yes, because such things have happened earlier too. On 1st September 1859, the Earth faced an intense geomagnetic storm, and because of this, many people could notice auroras or northern lights in region nearby equator. Many of the telegraph lines were induced with an intensely large current, because of which many of the lines were destroyed. Some people recall they could see bright, colorful auroras, bright enough to let people read newspaper during the night. Some people who operated the telegraph could even use the telegraph without even connecting the telegraph with a battery. The whole event lasted for 2 days and was known to the history as the Carrington event. After the scientist Richard Carrington, who along with another scientist, Richard Hodgson, who could map out the sunspots where the solar flare took its birth. Coronal mass ejection or CME are large-scale disruption of solar corona that results in the ejection of coronal material into the interplanetary space. It is kind of a scaled-up version of a solar flare, but it has a mass of about 1 billion kgs, larger than a solar flare. Another thing that is very unique about this case is that the kinetic energy from the blast of detaching from the sun is very high. This intense blooms of radiation that comes from the release of the magnetic energy is harmful enough to penetrate through the Earth's Van Allen belts. These are the magnetic fields that protect us from the flares and radiations coming from the space. They can take up to a day or 3 days to travel, but in the Carrington event that I was talking earlier, it took only about 17.6 hours to travel from the sun to the Earth. When these storms or CMEs hit Earth, they interfere with the magnetosphere and they are then termed as a geomagnetic storm.
When high magnitude of solar storm or a CME hits Earth's magnetic fields, the fields facing the sun gets compressed and the fields opposite to the sun gets elongated. The excess force on the Earth's elongated magnetic fields causes magnetic reconnection, after which there is an earthward injection of plasma particles. These are also called as charged particles, and this earthward projecting swarm of particles are collectively known as plasma sheet. These particles then interact with the Earth's atmosphere to form auroras.
The compression on one part of the magnetic field and elongation on the other part of the Earth's magnetic field will weaken the field enough to let some harmful charged particles get into the Earth's atmosphere. Though these are not so harmful for any living being, but there might be one danger. The magnetic field of the CME or coronal mass ejection can interact with the electrical equipment. Since this field is extraordinarily strong, this would cause a high power of electric current to be introduced into the grid line. The powerful electric currents that flow through the electric grid are likely to cause melting and burn through of large amperage copper. Many of the transformers will blast, and with a limited availability of electrical equipments, most of the regions will get affected by the collapse and would remain without power until new transformers would be built. But a typical manufacturer might require more than 12 months to manufacture these transformers. So bad days for the people who are totally reliant on the internet.
We are reliant on electricity, and all the tasks from washing the clothes to watching a show on TV requires electricity. In fact, many industries from the IT sector to the various manufacturing sectors are reliant on electricity. Without electricity, many industries will get paralyzed.
all of which could result in a market crash and economic crisis. Before we move further, does anyone remember the rumor that in 2012 the Earth was going to end? By the way, on 23rd July 2012, a CME missed Earth by just 9 days, and it would have caused a big issue as well as an economic loss of $2.6 trillion thanks to the rotation of both Earth and the Sun that we were saved from such a disaster. But the grid lines can be saved based upon the information gathered by various observatories. The grid lines operators can shut down all the electrical supply in the region with elevated risk to significantly reduce the damage to the grid lines. The charged particles that enter the ionosphere will disrupt radio frequencies by absorbing or reflecting it. During the geomagnetic storm, some radio frequencies get absorbed while the others get reflected, leading to rapidly fluctuating signals and unexpected propagation of the wave, which causes frequent disruption of public and amateur radio. It's not safe out of the Earth's atmosphere. Even astronauts at the International Space Station are not so safe considering how many radioactive particles and harmful rays are constantly bombarding this space station. When the CME bombards the space station, all its electrical equipments would get damaged, which would have resulted in difficulties in recovering the astronauts from the space station. But the recovery system already exists and can be used in case of an emergency to evacuate the station. Geomagnetic storm can disrupt satellite communication with Earth. The sudden buildup of charge will penetrate into the satellite's electronics and damage them, also sometimes alter the output of signal by the electronics, causing error to appear. Some errors are repairable, but if a higher magnitude wind or a storm hits, then damage may be irreparable. Satellites that are in higher orbits are more vulnerable to getting affected by a solar storm. But a recent event of about 40 Starlink satellites, which are placed in a low Earth orbit, deorbited and destroyed after a malfunction due to a solar storm. This shows the ability of solar storms to reach in the lower Earth orbit deep inside the Earth's shield like magnetic fields. Destruction of satellites also mean that the telecommunication and navigation will get disrupted. To sum up, a CME is the main cause of any geomagnetic storm. Though a low magnitude solar storm can be problematic for any satellite or humans in space. Read more blogs by StarSpace in the link given down the description, and please consider to like, subscribe and share. Thank you.